So now let's introduce bioinstrumentation. So bioinstruments are very important because they advance modern healthcare. So you see the operating rooms and emergency rooms and doctor's offices now filled with these bioinstruments. Because of that, the medical device industry is one of the largest and fast growing sectors of modern economy. So for that, there is a tendency that these bulky, big, very costly instruments inside a clinic or doctor's office, and that tend to be smaller and portable, and it's available lower cost to more like at home. So that is we call as a point of care or POC testing, which means the medical testing at or near the site of patient care, like patient's home. So let me show an example of point of care testing device, which is now more transportable and monitoring device for blood pressure. Now it gets smaller and cheaper, so even a home can have it. And disposable handheld device, for example, testing pregnancy. It's a nice, simple kit nowadays. It's a disposable and handheld device for such as glucose monitoring device and benchtop device. So medical devices now that can be used at home environment. So why is it useful in that case? The benefits are many. And for example, the patient can make a rapid decision making. Of course, this has to be dealt with a physician as well. And also operation times will be reduced. And also the patients need to visit the clinic or hospital. So as a outpatient clinic, visits will be reduced. So it's more convenient for the patient. So bioinstruments are like we can define as a sensors or actuators that is used in medicine or biological research. Because of the bio on the instruments, so it actually uses directly measures or connected to a living system, and that it acquires and processes and displays and transmits the biological data. So areas of biomedical engineering that uses these instruments are many. So for example, bioelectronics, and good example is cardiac monitoring or ECG, EKG monitoring device, and biomechanics, which measures, for example, tissue testing or like lung respiratory function test. And another example is biooptics, which is a optical imaging for disease diagnostics. A good example is an endoscopy, optical endoscope. And medical imaging is also another areas of using this instrument, such as a MRI, magnetic resonance imaging, PET, positron emission tomography, and CT, which is X-ray computed tomography. And these are like kind of instruments. So for the keys to successful engineering of bioinstruments will be first, we need to understand the physiology of the system, the biological system, or the patient and the pathophysiology, the physiology of the diseased organs or function of the system. And for instruments, we have to know the variables to be measured. And also knowing the function of the components of instruments, and also very importantly, the limitation of the instruments. For example, the range of values which is reliably measurable by the instrument, you have to know for this. So now let's discuss about general components of bioinstruments. So here it's a diagram showing. So we have an input, so which is we call measurand. So this is a measurand, is a quantity that is intended to be measured. So that's a measurand. For example, like we want to measure blood pressure, patient temperature, blood flow, chemical concentration, or voltage current, and those are the measurand, and that can be measured by sensor. So sensor is a part of instrument that detects the input and usually converts into a signal. Signals are now mostly electrical voltage here. So input can be a various of physical entity or electrical entity that converts into electrical voltage. So sensor is on the other way, it's called as transducer. So you remember in cell signaling pathway, there's a signal transduction pathway we call, because transduce means converting one type of signal to another type of information. So sensor is a transducer. Now you convert it into a raw signal, then there needs a processing for the raw signal. So further modification of the signal, because many times the signals are so weak that you need to amplify the signal. Also at the same time, signals usually comes with a noise. So you have to sometimes filtering out the noise. And signals, there are like your interest, signal of interest you can extract from the signal. So all these collectively, as we call signal processing. And after this signal processing, we need to get into the receiver, which is example like output display or recording. So it presents an interpretable message to humans or clinicians or to the patient. So in a nutshell, input is being sensed by the sensor or transducer to convert it into an electrical signal, and you process the signal, and then you into the receiver to display or record the results as an output. So next time we will discuss about the mechanism of bioinstruments and its detected signals into electrical signal and a performance characteristics.